You are walking through tall grass. Something moves near your foot. Your body reacts before your brain even catches up. You jump back, heart pounding, eyes locked on the spot where the movement came from. You didn't decide to do that. Something older than you decided for you. Most people assume this fear is just conditioning, something you picked up from movies or a scary story a relative told you as a kid. But the real answer is far stranger. That flinch is a piece of ancient survival software, installed by an arms race that started millions of years before the first human ever walked upright, and it existed for a very specific reason. Snakes have been trying to kill your ancestors since before your ancestors were even primates. Here's the strange part. You were built to notice snakes faster than almost anything else in your environment. In the 2000s, primatologist Lynn Isbell proposed something called the snake detection theory. She argued that the primate visual system, the very thing that gives you sharp color vision and a brain wired for spotting subtle shapes and clutter, evolved specifically because venomous snakes were one of the oldest and most persistent predators our ancestors ever faced. Researchers later tested this in labs. They flashed images of snakes, flowers, and other animals at human subjects for a fraction of a second. People spotted the snakes fastest, every time, even when the snake was barely visible in the frame. Why would your brain be that specialized? Because for tens of millions of years, snakes were one of the few predators small enough to hide in your immediate space and dangerous enough to kill you in minutes. You didn't inherit a fear of snakes. You inherited a targeting system. So by the time actual humans show up, roughly 300,000 years ago, that targeting system was already ancient. But detection only gets you so far. Eventually, someone gets bitten. And when that happened in a world with no hospitals, no antivenom, and no phone to call for help, what did people actually do? The first thing to understand is that ancient humans were not helpless here. They were remarkably well informed. Traditional societies across Africa, Asia, Australia, and the Americas independently developed detailed functional knowledge of which snakes were dangerous, which were harmless, and how a bite from each one would behave in the body. Anthropologists studying groups like the San of the Kalahari found that hunters could identify snake species by shed skin, by track pattern, even by smell near a burrow. This wasn't superstition. It was applied biology, passed down through direct observation over hundreds of generations, because getting it wrong meant dying. Once a bite happened, the first priority was almost universal across cultures. Stop the person from moving. Movement pumps venom through the lymphatic system faster, and ancient healers across wildly different continents seem to understand this intuitively, even without knowing anything about lymph nodes or blood chemistry. The bitten limb was often immobilized, sometimes splinted with wood or bark, and the person was kept as still and calm as possible. Panic raises the heart rate. A raised heart rate spreads venom faster. Somehow, without a single biology textbook, people worked this out through trial and error, and through watching who survived and who didn't. Then came the remedies, and this is where it gets genuinely fascinating, because some of them worked far better than you'd expect. Plant-based treatments for snakebite exist in nearly every traditional medicine system on Earth. Researchers cataloging ethnobotanical records have documented literally thousands of plant species historically used against venom, from specific roots in the Amazon to particular barks used across sub-Saharan Africa. Most of these had no measurable effect, but some did. Modern pharmacological screening has found that a meaningful number of these traditional plants contain compounds that genuinely interfere with venom enzymes, slowing tissue damage or reducing swelling. Ancient healers had no idea what a protease inhibitor was, but through generations of watching outcomes, they had built something close to an empirical drug trial, run in real time, with real stakes, long before anyone wrote the word pharmacology. What about the famous method, the one you've probably seen in old films? Someone gets bitten, a companion cuts the wound open and sucks the venom out. Did ancient humans actually do this? Some did. But here's the uncomfortable truth modern toxicologists have confirmed. It almost never worked, and it sometimes made things worse. Venom moves into tissue and the bloodstream within seconds, far faster than suction can remove it, and an open wound in someone's mouth risked infecting both people. Some traditional societies figured this out on their own and abandoned the practice, favoring immobilization and rest instead. Others kept doing it anyway, because sometimes a mild bite from a less dangerous snake would have healed regardless, and the ritual got credit for a recovery it had nothing to do with. This is one of the oldest problems in medicine, when you don't have a way to test cause and effect precisely. Coincidence gets mistaken for cure, and that mistake can survive for thousands of years. There's a darker layer to this story too. For a huge portion of human history, a serious bite from a truly venomous species, delivered deep into muscle with a full dose, was simply not survivable. No plant, no ritual, no amount of stillness could fully counteract certain venoms once they were established in the bloodstream. Skeletal and historical records suggest snakebite was a real and constant cause of death in many regions, particularly in parts of Africa and South Asia, where venomous species were common and population density was high enough for frequent encounters. Ancient humans weren't naive about this. Many cultures developed entire ritual and religious frameworks around snakes precisely because the threat was so real and so mysterious. Snakes appear as gods, demons, and symbols of both death and healing across nearly every ancient civilization, from Egypt to Mesopotamia to the Americas. That symbolism wasn't decoration. It was how people processed a threat they could not fully control. The real turning point didn't come from ancient knowledge at all. It came in 1895, when a French scientist named Albert Calmet, working in what is now Vietnam, developed the first true antivenom by injecting horses with small amounts of venom and harvesting the antibodies their immune systems produced. For the first time in human history, there was an actual counter to venom that worked at a biochemical level, rather than a folk remedy that worked sometimes, for reasons nobody understood. It's a strange thought. For roughly 300,000 years, every single human who survived a serious venomous bite survived either through luck, through the body's own defenses, or through fragments of plant knowledge that partially worked. Real, reliable treatment is barely over a century old, and yet the ancient instincts never left you. That jump when something moves in the grass, that instant spike of attention toward anything long and thin and coiled, that isn't outdated wiring you need to override. It's the same targeting system that kept your ancestors alive long enough to have children who eventually had you. Modern researchers studying venom today, scientists like Brian Fry, who has spent decades mapping how venom evolved across reptile species, are essentially finishing a project ancient humans started around a campfire with nothing but observation and fear. They are turning venom itself into medicine, using components of it to develop treatments for blood clotting disorders and chronic pain. The very thing that killed so many of your ancestors is now being taken apart, piece by piece, to save lives. So the next time you flinch at a shadow in the grass, you're not overreacting. You're running a program written by hundreds of thousands of years of near misses, close calls, and hard lessons your ancestors survived just barely long enough to pass on. That instinct isn't fear, it's inheritance.
Don't forget to hit that subscribe button right up there and check out this awesome video too.